probably be the easiest part as well, and it just flows on directly from B. I think some of us have made a start on B. So let's have a quick look up here. This won't take longer than 30 seconds, so we're going. So what we want to do, it's given us this quadratic and it says, determine the relationship between the graph and the x-axis. So that means we want to find delta first, okay? So we need our values of A, B and C. A is 1, B is -2, and C is +1. So delta is going to be B squared, take 4 times A times C, and so we've got 4 take 4, we've got 0. We've got the discriminant is 0. So we saw before, this means it has one double root. That's what it means. What does it mean in terms of the x-axis? If you graph this function, all right, this is what it's going to look like. It's going to be, it's x take 1 squared, so it's just going to touch the x-axis. So that's what a double root is where it just touches the x-axis. It doesn't cross it. It touches it and then goes back up. We call it a double root because it's just bouncing on the x-axis. And look, if you factorize this, this is what it is. It's x take 1 squared. And so we can start to notice a relationship here. When we have a squared factor, it's touching the x-axis. When we have just a single factor by itself, it's cutting the x-axis. All right, so that's the first one. Let's have a look at the second one. We've got delta is x squared plus 3x plus 4. Sorry, that's the quadratic. A is 1, B is 3, C is 4. So we're going to find delta, B squared, 9 take 16, -7. Okay, it's negative. All right? And so what we've got here, we've got no solutions. All right, that's what because delta is less than 0, the value of delta is negative. So that means it's not going to touch the x-axis. All right. The other thing we notice about this is that the value of A is positive. A is greater than 0, which means this quadratic opens upwards. All right, so it's opening upwards, but it has no roots. So if we're going to sketch this quadratic, all right, it's going to be completely above the x-axis because it's opening upwards and it doesn't touch or cross the x-axis. It can't be below the x-axis if it's opening upwards because then it's going to cross it at some point. This is a special case that we call positive definite. All right, we're going to say this function is positive definite because it is completely above the x-axis. All right, we know that because it satisfies two criteria. A is greater than 0, so it's opening upwards, and delta is less than 0, so there's no roots. It's not crossing the x-axis. The converse to that is negative definite. So if A is less than 0, it's opening downwards. All right, so that means it's going to be completely below the x-axis because there's no roots. All right, so negative definite would look something like that. So we have two special cases there that are written about in your notes: positive definite and negative definite. So our answer to the first one, what was it? Now it says state the nature of the roots. So touches the x-axis. And then over here, the nature of the roots are that there's no roots. The quadratic is positive definite. It's completely above the x-axis. If there are no roots, it will either be positive definite or negative definite. Okay, so that's enough to do 2D.4, and that's where we're at.